Theoretical recap. In Python, a variable is a named container that stores a value in memory. Unlike languages such as C or Java, Python is dynamically typed. You do not need to explicitly declare the type of a variable before assigning a value to it. Python infers the type automatically at runtime. The main built-in types you will encounter in security scripting are int, integers, for example, port numbers, float, decimal numbers, for example, ratios or scores, str, strings of characters, for example, IP addresses, usernames, URLs, bool, boolean, true/false, for example, flags for vulnerability presence, list, ordered collections, for example, a list of targets, dict, key value pairs, for example, HTTP headers, and none type, absence of value. To inspect the type of any variable at runtime, Python provides the built-in function type. For example, IP equals 192.168.1.1 followed by print type IP, will output class str. A common beginner mistake is confusing the integer 80 with the string 80. These are not the same type and cannot be concatenated directly. Another frequent error is forgetting that Python is case-sensitive. So port and port are two different variables. Keep your variable names meaningful and lowercase with underscores. Snake underscore case. This is PEP 8 convention and a professional habit to build from day one. Workshop brief. This hands-on workshop directly follows the lesson on basic variables and types in Python. Your goal is to write a Python script that declares a set of variables representative of data you will regularly manipulate in cybersecurity contexts, and then displays their values and types in a clear, formatted output. This is not just a typing exercise, it is an opportunity to develop the reflex of always knowing what type of data you are working with, which is critical when writing security automation scripts where a type mismatch can cause a tool to silently fail or produce incorrect results. Step 1. Set up your environment. Before writing a single line of code, activate the virtual environment you created in the previous activity. Create a new Python file named variables_types.py inside your project directory. Open it in your code editor. Confirm that running Python variables_types.py from your terminal executes without errors before adding any content. This setup step ensures you are working in an isolated, clean environment as expected in any professional DevSecOps workflow. Step 2. Declare your variables. In your script, declare at least one variable of each of the following types: int, float, str, bool, list, dict, and none type. The variables must be meaningful in a cybersecurity context. For example, a target IP address or hostname, a port number, a vulnerability severity score, a boolean indicating whether a service is vulnerable, a list of open ports, a dictionary representing an HTTP response, with keys such as status_code and content_type, and a variable representing an absence of result. Choose realistic names and realistic values. Do not use trivial placeholder names like X or var1. The quality and relevance of your naming choices will be part of the evaluation. Step 3. Display values and types. For each variable you declared, print a line that displays the variable name as a string label, its current value, and its type as returned by the type function. Format your output so it is readable and structured. For instance, a well-formatted output line could look like port, value, 443, type, class, and you are free to choose your own formatting approach as long as the output is clean, consistent, and professional. Avoid raw unformatted dumps. Think about readability. In a real security script, logs and outputs are read by humans under pressure. Step 4. Add a reflection block. At the bottom of your script, add a commented section using #comment lines where you briefly explain in your own words why type awareness matters in Python security scripting. One concrete example where a type error could cause a security tool to malfunction or produce a wrong result, and what the difference is between type and ICE instance. Look this up if needed. It is fair game. This reflection block is mandatory. It demonstrates that you are not just copying syntax but building genuine understanding. Step 5. Test, review, and submit. Run your script multiple times to confirm it executes without errors or warnings. Review your variable names and output formatting. Make sure the script is clean, readable, and commented where necessary. Once satisfied, save your file and submit it before the deadline. You have 2 hours to complete this workshop. Submit your variables_types.py file before the deadline expires. Late submissions will not be accepted.